Okay, in this video we're going to do a few example problems of the derivative. So we'll just make up a few position functions. It doesn't really matter what form they actually are making here. But we can do t to the third plus 4t squared minus 3t minus 6. Okay? So if we were to plug in any value of t, we would be able to figure out the location of that in that equation there. Make up another one as I'm doing this so you can get these started. It doesn't matter what order it is. You can start with negative 4 plus 6t squared. It doesn't matter whether you're writing it front or back, because you're still going to do the derivative of each separate term. So let's do this long one first. Our relationship for the derivative is dx dt is equal to, I think it was n times some constant times t to the n minus 1. Alright, so here we have constant 1, t to the n is our x form. So we have to take the derivative of x with respect to time, which is our velocity function. So dx dt is synonymous with velocity. So we have to multiply by 3, rewrite t, and write down the n minus 1. So 3 minus 1 is 2. So for this term, the derivative is 3t squared. Now we look at the separate term. Same format. Take our n, multiply it. 2 times 4 is 8t to the n minus 1. 2 minus 1 is 1. Okay. Minus, this is a 1. 1 times negative 3 is negative 3. T to the 1 minus 1 is t to the 0, which is 1. And then derivative of a constant is 0. So there is our first order derivative. First order derivative means it's the first derivative of that function. So here's another terminology that we're gonna use: first order, second order derivative. So we're going to take the second order derivative, which is the second derivative, basically the acceleration derivative of the position. That can be written as d2 dt2 of function x. But we just look at our first order derivative and we do the same formula. So that's n times c, which is 6t. 2 minus 1 is 1, 6t. Plus 1 times 8, which is 8. T to the 1 minus 1 is 0, which is 1. So now 6t plus 8 is our second order derivative. So this is our position, our velocity, and our acceleration. All right. So take a look at this one. Let's take the first order derivative, the velocity, of this function right here. Okay, so what is the derivative of negative 4? You should have said it at negative 4 is a constant, so that the derivative of negative 4 is 0. And if it doesn't have a t, it's going to be 0. 6t squared. Okay? And remember that x is ct to the nth power. That's what this is, ct to the nth power. So 2 times 6 is 12. T to the 2 minus 1 is 1. So that the velocity function is 12t. Take the second order derivative, is second order derivative with respect to time, which is the same as the derivative of velocity with respect to time, which is by definition our acceleration. Again, just showing the different types of notation. 12t You have a 1 as an exponent, so it's 1 times 12 is 12. T to the 1 minus 1 is 0, so t to the 0 is 1. 12 times 1 is 12. Our acceleration will be 12 meters per second squared for that function. It is the exact same process for whatever equation that you want to make up or whatever equation you're presented with. So let's give our position as t to the 5th plus 4 t to the 4th minus 3t to the 3rd minus 2t to the 2 plus 1t to the 1 minus, I don't know, 1,000, because why not? Doesn't make it more difficult, right? So let's take the velocity function, the derivative of position with respect to time. So 5 times 1 is 5, t to the 5 minus 1 is 4, and that's the derivative of this function right there. Okay, look at this term. Okay, 4 times 4 is 16. T to the 4 minus 1 is t to the 3. 3 times negative 3 is negative 9. 3 minus 1 is 2. Negative 4 t. 1, 0. So here's my velocity function. Acceleration, again, all it is doing another derivative. 4 times 5 is 20, t to the 3rd. Oh boy. 6 times 3 is 18. So that's 48. T to the 2. That's 18t to the 1 minus 4. So you start to see the trend here. Hey, let's do it again. Let's do the jerk, because the derivative of acceleration is jerk. So we have 3 times 20 is 60. T to the 3 minus 1 is 2. Plus 2 times 48 is 96. Is that right? It's been a long day. 96t minus 18 plus 0. And you can keep going, because you have, you're not going to get a constant until you do the 5th order derivative. So I don't know what it's after jerk. I think it's called snap. Let's do snap. Okay, 2 times 60 is 120. T to the 2 minus 1 is 1. Plus 1 times 96 is 96. Plus 0. So jerk, snap, whatever you want to call it. We can do 1, 2, 3, 4, 1, 2, 3, 4, d5x dt to the 5th, okay, is going to be 120. Who knows what those units actually would be, okay? So it's the same formula of if you are given position as a function of some constant times time to the nth power, that the derivative of x with respect to time will be n times c times t to the n minus 1. And this is all we really did for any of those derivative functions. So at this time you should, at least what I would consider enough practice, be able to complete the derivative section of your summer assignment. At this point in time, you do not feel confident with your answers for your summer assignment, make sure you send me an email.